Alright guys, so on Monday, except for these sparks, when you take the exam, it'll be over chapters 1 through 4, and we made a mad dash through chapter 5 in one go, so we could conceivably have thrown in some stuff on it, but it covers chapters 1 through 4. That's what it's designed to do. So what have we done in chapter 5 that is cool, that if we had attacked this a little bit more aggressively, we might have been able to include chapter 5 on the exam, and that was the idea of loops. Right, loops, nested loops, for loops, while loops, etc. But I want us to have more experience with that. I'm not going to just throw it on the exam after one lecture. I guess today would be a second lecture over it. So the next topic is files, using files for data storage. And again, I question sometimes how the book organizes things, but it's worth throwing in files here at this point because the way you read from a file is to use a loop. You get data from the file and you keep reading until the file is done, until you've gotten it all. And so you use a loop in order to do that. But our first use of the file is not going to be to write, not to read so much as it is going to be to write. So you can use files instead of the keyboard and the monitor for input and output. In fact, most of the time that's what's done. That allows data to be retained between program runs. You wouldn't want to have to sit there and key in the census data for the state of Oklahoma every time you wanted to run a report. Instead, you save it all to a file. And then later on, your other program opens that file, reads from it. It's actually stored in a database, but before databases, there were just files. And what is a database? It's a collection of files. So your steps: open the file, use the file, read from it, write to it, or both, and then close the file. We use fstream for file access. # include fstream. There's ifstream for reading from a file. There's ofstream for reading to a file. And then fstream allows doing both. And so we have two different file stream objects. And here's this word stream. Every time we've done the arrow, that's called a stream operator. Writing to a file is as easy as using the arrows, just like it was cout. Except instead of cout, there'll be your own variable there, which represents a file you're writing to. Quite often I just make it fout, right? Make it look the same. So it'd be fout, arrow, hello world, that kind of thing. Or if you're reading in, instead of being cin, arrow, it'll be your variable, your file variable, arrow, x or whatever. And so instead of cin, sometimes I just use fin, arrow. So to open a file, the act of opening a file is creating a link between the file name and the file stream object. So really what it's doing is it's asking the operating system to establish a connection to a series of bytes on your hard drive of the specified name, and then you can send data to that file handle or read from it. And so you use the open member function. We haven't talked about member functions much. That's because that's an incorrect term. It should be method. A method is a function that's attached to a object. A method is a function that's part of a class. So technically .open is a method rather than a function. But the terms are kind of synonymous, but not really, because if it's part of a class, you'll never use a function that's preceded with a dot like that. It's a method, but a method is a function that's attached to a class, an object. And so there's our object, and we call .open on it, and we give it a file name. And C in the operating system should wire things up so that we can then read from the file. Or if it's an OF stream and we want to write to it, it should establish a connection so that we can then start writing to the file. We can include the drive, the path info, C:\\, whatever, you can make a fully qualified file name. The output file will be created if it's necessary. The existing file will be erased if we're using an OF stream. The input file has to exist for open to work. So if you're using an IF stream, an input file stream, and you open the file, you'll get an error if the file does not exist. If it's an OF stream, it will create the file. It doesn't have to exist, and as a matter of fact, if it does exist, it will erase it. So testing for open file errors. Here's how you open your file. And this just looks silly. But this is how it's done. If not in file, cout file open failure. Or you can use the .fail member function. In which case it would be something like this. If in file.fail. We'll get that exact syntax going in just a minute. I'd rather see that than just not in file. That's way too C++ specific. It's taking advantage of the fact that underlying C++ is C, and as far as C is concerned, any if statement that evaluates to 0 is false, and anything that evaluates to non-zero is true. And so if in file open fails, then we don't have a handle, and we can say not 0, and what that would have turned it into is a 0. If this is actually 0, then it would go in here and print file open failure. It's kind of silly, but you can use that syntax. It's perfectly good. Probably the syntax we'll use just since we have the example of it. You can use the output file object and the stream insertion to send data to the file. Out file, my inventory report. You can use the input file object and arrow to copy data from file, two variables. In file, part number. In file, quantity and stock. So the stream extraction operator returns true if a value is successfully read, false otherwise. And so you can throw it in a while loop. You can do this. This will continue to read as long as there is data in the file. This will keep returning true as long as there's still data in the file. And then we use the .close member function, file.close. You don't have to. Once the program exits, it will close the file, but that's obnoxious. Don't do that because there may be a limit on the number of open files that your current operating system provides. Now nowadays, with Windows 10 and whatever, we can open, thousands upon thousands of files simultaneously. But, not all operating systems and all platforms will let you have a lot of files open. And so if your program opens a file and doesn't close it, then that's a file handle that another program couldn't be able to use. Also, if you have the file open, the operating system may have it locked, and it may be that nobody else can access it. That a backup program would not be able to, make a backup of it. That something couldn't copy it to somewhere else. So you want to generally close your file as soon as possible. You read from it, you do all your reading, and you close it as soon as possible. As soon as you're done writing to it, you close it. You don't want to keep it hanging out. There may be buffered outputs waiting to send to the file. If you've written to the file but you haven't closed it and then your program crashes, then maybe it's not all really written out there because it was buffered sitting there waiting to be written, and the program crash interfered with that background update. So in many cases, you want the user to specify the name of a file. The name of a file is a string, just like any other string, any other name. So you can pass a string object as the argument to the file stream object's open member function. So when we call .open, we will either pass in, a character array, a literal like that, or more likely we'll put some data in a string and open it. It'll be like in file open file name, like that. So in order to use our file, we've included the F stream header file. This is going to be an input file, so we use IF stream. If it was going to be a file that we were going to write to, we would use OF stream. And then we have another variable declared to hold our file name. Get the file name from the user. Cout, enter file name. CIN, let them type it in. And then open the file. Input file.open using the specified file name. If it opens successfully, process it. So if the input file exists, then read the numbers from the file. While input file, arrow, arrow, number, do something, and then close the file. Else, display an error message, could not open the file. And it'd be nice to print the file name so that they could have a chance of figuring out what was wrong. So, prior to C++11, the version that was created in 2011, the open member required that you pass the name of the file as a null terminated string, as a string array, as something between quotes, which is what's known as a C string. That's what the language C gives you. The C language does not have this cute string class that we get to use. So string literals are stored in memory as null terminated C strings, but string objects are not. And I've had people who did not use Visual Studio, and they went and they installed another C++ package on their computer, which is totally fine, but one person managed to find one that had been written before 2011. And so it did not support passing string variables into the .open function in order to get the file to open. So instead, had to call it like this. File name .c_string would turn it in to a C string that could be opened by that .open method. Just like this. Input file .open, file name. This is what we get to do with any recent version of C++, but before that, you'd have to do that to extract the string array from it to be able to use it. Breaking and continuing a loop. All right, well, that's enough about files. We know everything. Why don't we write some examples? Let's actually write some code that will save some data to a file. Empty project. Let me guess, I still haven't made a boilerplate yet. Nope. Guess I will this time. Add new item. I'm going to call it today's date, June 27. IO stream. F stream for files. String. Using namespace std. System pause. Return 0. And that'll be my boilerplate. Let me save that. All right, let's just write a series of numbers out to a file. But let's ask the user for the file. So cout, enter a file name to write to. That means we need a variable to read in from. So string file name, cin arrow file name. Let's try to create that file. We're going to write to it, so we need an OF stream, an output file stream. So OF stream, I'm just going to call it fout. You can call it anything you want it to. You can call it Fred, fout. And then fout.open, passing in that file name. Let's write something to it. Fout, less than, hello, exclamation point, \n. End quote. Now this is bad programming because we haven't validated that the file exists before we started writing to it. We're just starting off, baby steps. Now let's close our file, fout.close, and let's pop open Notepad in order to view the contents of our file. And we're going to do that with a system call. We're not going to normally do this. But Notepad, well, that's not good enough. Let's make a string that contains our command to open the file. So string cmd is equal to notepad.exe space end quote plus file name. And then let's call the system call to access that. System run that command. System doesn't like us using strings. Alrighty, so cmd.c underscore, just like that page was talking about. cmd.c underscore, oh come on, c underscore str. That. Let's see if this actually printed the word hello to that file. All right, enter a file name to write to, june27.txt. And it created our output file, and it opened it. All right, now are we normally going to be throwing this in there? No, but if we hadn't have done that, we'd have to go and find the file to open. What do I mean by that? We'd have to go here, we'd have to find our documents, we'd find our C++ projects. There's today's date, there's the project folder, and there's my june27.txt file. And that's actually a better way to do it, but just for playing around, I want us to have instant gratification. We created a file, it has the word hello in it, and we can go and find it. It's in the directory as our .cpp file. So when the program runs, it created a file in that directory because we did not specify another directory. Could have, like if you have a flash drive, and you know your flash drive is F or whatever, you could specify the file name F:\/ my homework / whatever, and it would have written to that instead. Everybody get that part working. So I'm amazed that this has actually worked. The problems that we could have seen is if I had left the space out of there, like that, then the command that it was trying to open would have been something like this. Notepad and then june27.txt with no space. That doesn't work. Notepad is the name of the app, and then we want the file name separated by a space. So that is why we needed a space there. And that was fairly subtle, and so I'm not surprised that not everybody typed it. Now, of course, this is a very Microsoft-specific thing, so if you're sitting there on your Mac or your Linux machine, it's not going to work. But that's just a shortcut for having to go out here, finding it in our projects directory. When we're writing our own programs and you want to create an input file and then run your input on it, you know, you have a couple of choices. One is that you could store it, you know, and then provide the whole directory to it when you say that what file you want to open. Or the other is that you could drop it in the .cpp directory and open it from there. So, okay, we have something that writes hello. Let's come up with something a little bit more interesting than that. Yes, sir?
Whenever I asked for the file name, I typed in June 27, and it only titled it June.
Well, that's weird.
What did you do with that 27? So, I run it.
this is telling us that you can't have a name with a space. And we know that to be a lie. I know why, because CIN tokenizes your input, so when you type in June 27, June is getting stored in the file name, and that 27 is still waiting there, out there, and so
So if I had other data waiting to collect, it would stick it
it would stick it in there
Okay.
instead, right. So yeah, make your file name all one word unless we're gonna change to using a get line command. Very good point. I want to demonstrate that here. If you ran it and you changed it to my file or my space file.txt, which is a totally legit legal file name, it would just be called my. And the reason for that is since we use CIN arrow arrow in order to get it, the file name variable contains just the first token, which is the word my. And then out there in the buffer is still waiting as lurking data, file.txt, to mess us up on our next read from CIN. So let's make a little loop that'll let us write to a file instead of just writing f out. And let's do this a little bit more legit. Let's do the bare minimum of error handling, which is just to check to see if the file got opened. If, I'm putting this above that hello there, if fout dot fail, cout could not open file name space end quote arrow arrow file name arrow arrow endl. Else we are good to go. So else open brace. Delete that line that says f out hello. We're not going to do that anymore. Let's ask the user for some data. Enter a series of numbers. Cout use -1 to terminate input. So we're going to declare a variable and then we're going to write a loop. Guess these could be doubles. So let's read in to our number variable, and then let's do a while loop. While number is not equal to -1, let's write that number that they just typed in into the file, and then get our next number. So f out, we're not going to display the number, we're sending this to our file. F out that number, followed by endl. And then let's get our next number. CIN arrow arrow number. Now this bit about closing the file and opening it, all of that stuff actually needs to be part of this else. So you see this closing brace here that terminates the block of the else block? We actually need this code to be before it. So grab your fout.close, your notepad.exe, and your system call. Cut those and paste them above that curly brace. right? Because we want that part of our else. We don't want to try to open the file if it wasn't created. File name to write to, June27.txt. Enter a series of numbers. I need to increase the size of the font here. Alrighty. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, -1. And there's our file with all of our data. You see this line up here that says if fout.fail, you can remove the .fail and the parentheses and the end parentheses, and it works just as well. I just personally hate that syntax, but it's certainly easier to type. So what we've done here is we made this if not, and it prints out that error message, and then we say if fout, and that works. So what's happening is it's just ultimately resolving this to either a 0 or a non-zero value. And if you call fout all by its lonesome without giving it any functions, then it returns a 0 if it wasn't opened, and it uses that as a trigger of the if. If it's a non-zero, then it's actually validated and we can run with it.
If you title the file asterisk.asterisk, it's an illegal file name, and it'll return the error, and so you couldn't find it.
Oh, cool. Let's do that. Cool. What if we give a file name that can't exist because it's a drive letter that we don't have? For example, what drive letters do I have? Net use. I've got R, V, W, X, and Y. I don't have Z. And most of these are probably read-only anyways, but I'm going to specify Z colon output.txt. Cannot open. All right. Let's make sure it actually does work. I haven't given it any good. All right, good.
So by default, it just sticks it wherever the CPP file is?
Correct, correct. That is correct. Yeah, so by default, it is creating our output file in the current directory. And you can specify other directories if you want. Looking something up. Well, that's certainly not what I was expecting. So if I run it, this that I typed, that I just copied and pasted, when you're running in this command prompt, you have environment variables. And if you want to use them, if you want to find out what something is, if you want to, I could do echo %username%, and it would tell me J.G. Thompson. So can I can I use that as part of my file name and have it get expanded? When I run it, can I do %username%.txt, and it may say jgthompson.txt? I'm curious. I wonder what it created. All right, well that didn't work. So when I called Notepad, I was using the system command prompt in order to do it. That's what that system parentheses means, is invoke the operating system to open it. And so it did expand %username to be J.G. Thompson. But C++ did not. So there has to be a way of querying the operating system, asking it to tell you the contents of that variable so that you could use it. Because there's all sorts of useful ones. If you look here, okay, there's way too many. But like if you want to a temporary directory to write to, you can query for the temp environment variable. If you want to know the user's current username, you can do that. If you want to find out what their home directory is, you look at user profile, and so on. So it would be really nice to know how to access environment variables from within the C++ program. Kind of going off base here. Get environment variable function. Not going to mess with it anymore. Okay, so we've seen that we can write to a file. Now let's read from that file. Let's write another chunk of code that will open a specified file name and read from it, displaying everything on screen. So, again, let's ask for the file name. Cout, open a file name to read from, colon, space, end quote, semicolon, CIN arrow arrow, file name. This one's going to be an OF stream because it's an output file. No, the last one was an output file. This is going to be an input file, so it's going to be an IF stream. IF stream space FIN. Just like CIN is input from the console, FIN is going to be input from a file. So fin.open file name. Let's see if we got it. If exclamation point fin, or if you prefer like I do, if fin dot fail, parentheses in parentheses, let's tell them that we couldn't open a file. Could not open file name space, end quote, arrow arrow, file name, arrow arrow, ENDL. Else, let's do it. Let's read in everything that's in the file. Now I'm hoping that they're words, I mean that they're numbers, but we don't really know that yet. So for our first iteration of it, why don't we just read in everything as strings? So string S. I'm not going to come up with a better variable name than that. Okay, so fin while fin arrow arrow S, and again this looks slightly alien to me compared to the way that some other programming languages do it. That may look Python S though. I'd have to look it up. Let's display what we just read. So cout just read colon space end quote arrow arrow S arrow arrow ENDL. After the end of the while loop, we're going to close our file, fin.close.
typed fin.close, would it close everything or just the last thing you access?
Yeah, if you have multiple files open, does this close them all? No, because if you had multiple files open, you'd have different file names, like that.
Oh,
And then
I
you'd
see.
call fin2.close, fin3.close. Very good question. All right, so now we're creating a file, 1, 2, 3, whoops, I just called it 1. That was dumb. All right, then -1. That's my file. Open a file name to read from. I guess I'm going to give it the same file name. And it just read 2, 3, 4, and 5, which are what I just wrote to it. And run it again. My.txt is my file name. Enter a series of numbers. 1, 2, 3, 9, 10, 11, 12, -1. All right, and there it is. But what if I edit it? What if I type in something else into here rather than just say, so this is my Nito file. I'm going to save that and close it and then let it read from it. Open a file name to read from. Should be open. It should be enter a file name to read from. My.txt. And it did read the contents of the file as I modified it. My.txt. This is my Nito file. We could probably skip that notepad stage at this point. It's just something that we have to close in order to continue processing. We might comment it out. I guess it's okay leaving it there.
Mine's only reading the first number and then closing.
Interesting. A very good point is that the reason we're able to open these files with Notepad is that these are text files. Why are they text files? Because that's all we've been doing, is displaying text to a console window and reading text from from the keyboard. That's obviously not the only kind of file, right? If you're going to open a photograph, it would not be opened in text file mode. So in this fin.open command, there are a lot of alternatives. I used to just be able to highlight the function, hit F1, and would it magically find me the helps page for it? Alrighty. So, there's an optional parameter called mode. Eight, seeks to the end of a stream when its controlling object is first created. Out, to permit insertion into a string. Trunc, deletes the contents of the existing file. Is this making me think that we could append to it? Yeah, to seek to the end of the file before each insertion. So if we didn't want to erase the file every time, we could be opening the file in append mode. And it would look like this.
Is that just tacking on when we wrote through the file?
Right. So down this fin.open, right. So we're going to make it so that it appends whatever we enter this time to what was already there in the file. Let me paste that so that I can steal from it. Okay, so file name, comma, iOS underscore base colon out. And then a vertical bar, the shift of the backslash above the enter key. And then iOS underscore base colon app for append. So t.txt, I think I already have a file called that. You enter a series of numbers. I'm going to try to distinguish my new data by entering very large numbers. Hit -1. Alrighty. I can't say that that worked.
Shouldn't we have that on the F out part instead of the F in?
Yeah. Yeah, that was dumb. This stuff should have been on the F out. So just cut it. Find your F out statement. F out dot open and put it there instead. Thank you. I was getting slightly miffed. All right, file name to redo. T.txt. To write to, I mean. Enter a series of numbers. All right, and yeah, it did. So, what would be really nice is if we check to see if the file existed. And if the file did exist, we asked the user whether they wanted to overwrite or append. Off the top of my head, I don't know how to do that in this language, so we're going to find out.
Just do an F statement and then have only have that new language in there on the branch where they said, I want to append. And then if not, it's just going to override it anyway, right?
I'm not getting that yet. Let me read what I'm trying, and then I'll try to get that again. You try to open it as an input file, and if it exists, then you know that it does exist. I guess that makes sense. We're almost making the code too complex at this point. But what we could do, yeah, I'm going to run it again, and then I'm going to specify a file that doesn't exist for reading. So I run it, t.txt. I'm not going to even enter anything because I know that we've been appending to it the whole time. That's great. Now, read from that same file, but I'm going to mistype that file name, t2.txt. I know that file name does not exist. It says cannot open file name. So if you try to open an if stream, and the file doesn't exist, you know that it doesn't. There's got to be an easier way, but that is one way to see if the file exists. Let's write a little function called if file exists. So up above main, I'm going to write a function bool if underscore file, or how about just file underscore exists, parentheses string file name. So ifstream test.open, parentheses file name, bool OK is equal to false, and then not book, bool OK is equal to false if parentheses test, then that means it's good. OK is equal to true. Close our file and then exit. Test.close, and then test.close, parentheses, in parentheses, semicolon, return. OK. We've written a little function for checking to see if the file exists. Again, that if test really bugs me, so I'm going to modify it to use my preferred syntax, which is if not test dot fail, parentheses in parentheses. So down here, where we say enter a file name to open to, CIN arrow arrow file name, let's find out if it exists. So where we say OF stream F out, trying to get this all onto one page. So underneath that line where we declare OF stream F out, if file underscore exists, parentheses file name, I forgot my opening parentheses there. I'm wasting time on stuff that I shouldn't here. Okay, so if the file name does exist, we're going to ask them. Cout, file already exists. Do you wish to append to it? Do you wish to cout arrow arrow? Come on. A, append, or O, overwrite? Question mark. Now let's declare a string for holding the answer to that. Let's just call it mode. String mode, CIN arrow arrow into mode. If mode equals quote A, end quote, we want to open it for appending. And so take that line that we did down there, this F out open line, and paste it there. And I didn't put parentheses around my if statement. Else, paste that F out again, but take that APP off. In fact, take all of that off. And then lastly, we need one more else. If the file didn't exist, we're in the clear. We're just going to open it. And so paste your F out statement one more time. Now that's by far not the cleanest way we could have handled it. Having this three versions of F out is pretty nasty. I guess I should run it before I wait for y'all to finish typing it in, because what if I have an error? T.txt. File already exists. Do you wish to append or overwrite it? O for overwriting, enter series of numbers. Well, that wasn't a number. That was smart. Real smart. Okay. Once more with feeling. T.txt. Override it. Enter a series of numbers 1, 2, 3, -1. Worked. Test it again. Opening it for appending. t.txt, append 1, 2, 3, 4, -1. Okay, so that code is working. I don't know why I got a bee in my bonnet about making that one work, except that that's just kind of the thing that you would actually want to put into, you know, a program that you were writing if you were giving this to somebody else, because they'd be unhappy if they accidentally overwrote, you know. Just like when you're creating a new file with Word and you try to do a save as, and that file already exists. It asks you if you wish to erase it or not. Hopefully they know that A means append and O means override. But if we were really awesome, we would give them the third option, which would be to pick a new file name. You don't have to do anything like this in the homework that I assign over files. Yes, sir. Totally rebuild it. Rebuild project. Rebuild solution. All right, this is not the solution, but it will at least mask the problem. Move the cursor in front of the CIM. Here's the real problem. See what's going on there? We just have two closing braces. Now we don't have to have that STD colon, but. Okay.
Thank you.
Sure. Alrighty, guys, why don't we take a break? Get back at 8:30. Caffeine acquisition or bathroom or whatever. Alright, I had the recording paused. So, to play catch up, what we did is we took our main and we renamed it main 2, so it would no longer run. Then we created a new main. Inside this main it looks like this. Cout 1 to create file, 2 to read from file. Declare our variable called choice, string choice. CIN arrow into choice. And then we have this branch of code. If choice is equal to 1, declare our file name, create our output file stream, cout save data to what file, read into the file name, open that file. If the file exists, great, else display an error message. So that's what this code needs to be. I'll zoom out a little bit. You can finish typing it in. Oh, and then underneath that is just our system pause and our return. Pause the recording, get your stuff in, and then unpause it. What would be even double niftier is if we put all of this code in its own function. But I'm going to leave it alone. Let's go down here, and if the file was successfully created, let's just have a while loop that writes, 100,000 numbers to it, or a for loop. For int x is equal to 0, x is less than 100,000, 0, 0, 0, 0, 0, x plus plus. And then O file less than x. Less than NDL. And then after our for loop is done, let's close it. O file.close. Now this version of it doesn't have the code to use Notepad to open it and inspect it. So when we run it, if we want to see what it created, we'll just go out to that folder and look. I'm going to add a comment, write 100,000 consecutive numbers. Can't spell consecutive. To the file. One, to create the file. Two, to read from the file. Save data to what file? T.txt. That was pretty fast. What if we wanted to know exactly how long that was? Just for funsies. In front of our for loop, do this. Cout arrow arrow time parentheses 0. Arrow arrow ENDL. And it's going to tell us it doesn't know what the time function is. So why don't we go and get that. The ctime library. Let's come up here and add # include ctime. # include parentheses ctime. Not parentheses, angle brace. # include angle ctime end angle. Now that I've got that, # include, I'm going to go back down to my code here and look, make sure it's working now. So there's that time. And after my for loop, I want to print that out again. Time 0 ENDL.
So what is the 0 argument?
Good question. We'll find out very soon. I'm acting like I'm posing that as a question to you. All I know is that every single time I've used it, I've always passed a null or a 0 to it. And we're going to find out because you asked. Save data to what file? T.txt. All right, so that took about no time at all. Interesting. Okay, let's look up that function and see exactly what that does. So highlight time, hit hit F1. The time function. Oh, it takes a pointer to a timer object. Returns the number of seconds since midnight. That's not very good resolution. I was hoping that it would be something like milliseconds rather than seconds.
Maybe get the current time, seconds since current time?
Yeah,
Since,
there's always like 1,700 different time functions you can call on these things.
wow.
I'm exaggerating slightly, but so there's a time t structure. You can set the time zone from the time zone environment variable. All right, and then display the time. And then get the date. Get the Unix style time. Display it as a numbered string. So we're passing in a structure so that we can then extract information from it. There's a structure called time_t, which you can then pass in, and if you do pass it in, then it comes back and it has some interesting information. And then if you want to convert that to a a current time, you pass that in to C time. But I wanted the number of milliseconds. I didn't want the number of seconds. Oh, that looks way too hard.
Like clock.
I should have had this prepared before we got in the lecture. I'll stop. Yeah, here we go. Clock. Wow. And then if you wanted milliseconds, just multiply time by 1,000. Give me a break. How about get tick count? Forget it. We can get the time in the seconds. That'll probably be enough. Here's what we would do. Make an unsigned long. Unsigned long. And set it equal to time, parentheses 0. I forgot to give it a name. Start time. Unsigned long start time is equal to time, parentheses 0. And then after our code runs, we're going to do the same thing, but we're going to get a stop time. Unsigned long stop time equals time, parentheses 0. And then int seconds is equal to stop time minus start time. And then after that, we're going to print out how many seconds it took. Cout seconds equals space end quote arrow seconds arrow ENDL. And since 100,000 was a very many to write, I'm going to change it to 500,000. 1, 2, 3, 4, 5, 6. Okay, so it took about 6 or 7 seconds to write 500,000 entries. Let's change it to 1,000,000 then. A 1 followed by 6 zeros. 1, 3, 3, 3, 0, 0, 0, 0, 0, 0. All right, took 12 seconds to write 1,000,000. That's kind of interesting to me. I'm sure that there are ways of optimizing the speed of writes so that 1,000,000 writes would not take very long at all. But on the other hand, writing something 1,000,000 times in 12 seconds is pretty cool. All right. Basically, I wanted you to have the idea that you can measure the how long a process is taken by doing that. However, seconds resolution is a really lame way of doing it.
Really big number.
Let's add a little something here that will display something on screen so that we know it's doing something. So why don't we do this? If x mod 10,000 equals 0. Then see out a dot. That means every 10,000 times it runs, write a period. Now that 10,000 may not be large enough because it's going to write out like 1,000 dots. Let's make it every 50,000. All right, that way at least we see it doing something. We don't know how many dots it's going to display, but we do know that it's doing something. All right, I'm kind of happy about that. So how is this working? What does it mean if we mod by something and we get 0? It divided evenly, so every 50,000 iterations of that loop, it's going to print a dot. So lastly, why don't we just ask the user how many numbers they want to write? See out, how many numbers do you wish to write? Question mark. Space. End quote, semicolon. And then let's declare a limit. Now the max that an int can hold is 2 billion. I think that's a fair limit. So int limit is int limit semicolon CIN arrow end of limit. And then instead of 1 million there, replace that 1 million with the word limit. All right, clearly if you type in a small number like 50 like I did, it returns just about instantly and it says seconds is equal to 0. All right, again we've made the example more complicated than what I really want. Here's what one of the homework assignments is going to be over this stuff. Homework. There's something that I wanted us to do that I don't think we've done yet. Homework assignment. Getting sloppy. Where is... So I want you to tell me if we've done this homework assignment or not. Usually I've assigned it far before now, but I don't see it there. So the BMR assignment. BMR stands for basal metabolic rate. We will write a program which asks a person for information about them and then calculates the number of calories that they are burning each day and displays the results. So your input, their weight in pounds, their height in feet, their age in years, and then an activity index multiplier as described below. Declare all the variables as double. So based on the 3 factors that they enter, the weight, the height, and the age, we will calculate their basal metabolic rate, the BMR. The equation for BMR in terms of weight, height, and age is this. That's just a little formula. Once you have the BMR, you can figure out how many calories that a person expends a day based on their activity index. Like if you're a couch potato, have an activity index of 1.2. If you're Michael Phelps during Olympic season, you have an activity index of 1.9. And then so then we can calculate the number of calories that they burn at that index. So a sample calculation. Imagine a person with the following data. 135 pounds, 5.5 feet, they're 61 years old. Their activity is sedentary with little or no exercise. So the AI is 1.2, according to our little chart here. We do the calculation. That's their BMR, 1326, and then the total calories burned each day, according to that. Now this is really distressingly precise. I really doubt it's that precise. But anyways, note all the calculations are approximate. Okay, so here's a sample run. To advance your health, we will calculate how many calories you burn a day. We will need data on your weight, height, and age, and what kind of activity you do. Please enter your weight in pounds and press the enter key. They type in something. Please enter your weight in feet. Press the enter key. They type in something. Please enter your age in years and press the enter key. They type in something. And then these are activity indexes for different lifestyles. Please select yours, and we display all of these different options. And then it says, based on this information, what is your activity index? And they type in 1.2. Then it says, here are the results for our computation. You burn that many calories every day. Thank you for using the Rose State College calculation. Okay, so that's how the program I want it to look. Then, for this assignment, I was going to have you modify it so that it stored its output to a file, right? It just created a file that contained these 4 lines of information. But you haven't done the first one yet. So guess what? You get to do both now. Okay, so part 1 of the project. I guess I'll make part 2 an entirely separate file. So part 1 is just going to be this, and then part 2 will be modify this to just save its output as a file, right? So it's 2 completely separate assignments. One is to do this calculation, and the other is to modify the program so that it saves to a file. Ask the user for the file name and then save it to that file. So I think at this point what I want to do is we're going to do one more example of file I/O. File output, actually, not file input. And then let's go over the exam material that's coming up. And we may end slightly early. Okay, so where it says cout1 to create file, let's modify that statement to 1 to create numbers file, 2 to create address file. And now I'm just going to do if parentheses choice equals 2, quote 2. So again, we're going to need a file name, string file name, and then OF stream F out. So let's get some good information from them. Cout. Let's declare our variables first. String, street number, right, street num, comma, address, or street, city, state, zip. And also first name, last name. So string, F name, comma, L name. So this is going to say C out, arrow, arrow, enter the address information, \n, end quote. So C out, arrow, arrow, quote, first name. Colon, space, end quote, semicolon, and let's read into the F name variable. CIN, arrow, arrow, F name. C out, arrow, arrow, quote, last name, end quote. Or colon, space, end quote, semicolon. CIN, arrow, arrow, L name, semicolon. And we're going to do this for each piece of information: the street number, the street, the city, the state, and the zip. Now, if we were using get line, read line, to read in an entire line, it'd be better, in a way. Because this isn't going to let a street name have two words in it. You know, it's just going to be one word only. But just play within these limitations. So C out, arrow, arrow. What is the street number? Street. Is that what it's called? Like if you live on 123 South Main, what is 123 called? Street number good enough? Example 123. CIN into street num. C out, arrow, arrow. What is the street name? Parentheses, one word only. In space, end quote. CIN, arrow, arrow. Street. The longer I look at this, the weirder the word street looks to me. Does that ever happen to you? You're looking at a word and it just looks alien. Alrighty, C out, arrow, arrow. What is the city? I guess since we didn't say what is the first name and what is the last name, I'm going to change my prompts to just street number. I'm taking out the words what is the street name. City, parentheses, one word only. In parentheses, space, end quote, semicolon. CIN into arrow, arrow, city. C out, arrow, arrow, quote, state. Question mark, space, end quote, semicolon. Two letters. Tell them that. So state, question mark, space, two letters. CN, arrow, arrow, state. All right, and then C out, arrow, arrow, zip code, question mark, space, end quote, semicolon. I've got the arrows going the wrong way. All right. C out, less than, zip code. CIN greater, greater than, zip. All right, we have all that information. Now we want to print it, print it as an address. So we're going to want first name, space, last name, then go to the next line. And then, you know, street number, street, city on the next line, and then state, and then zip on the third line. Before we try getting that to go to a file, let's just display that on screen first. So, I'm going to add a comment here. Display address. Cout arrow address colon \n end quote semicolon. Cout arrow fname arrow space end quote arrow lname arrow endl. And then do the same thing for the street number, the street, and the city. So cout arrow street num arrow quote space end quote arrow street arrow space end space or quote space quote arrow city \, not \, endl. And so cout arrow state arrow quote space quote arrow zip arrow endl. And then that's enough at this point. You're going, that's more than enough. All right, so we've gathered in a lot of information and we've displayed it. And if the display works, then we'll turn around and we'll save it to a file as well. But I want to make sure that we get this much running first. Create address file. First name, Joe. Last name, Bob. Street number, 123. Street name, Maine. City, Tulsa. State, okay. Zip code, I have no idea, 75075. All right, address, Joe Bob, 123 Maine, Tulsa, okay, 75075. Is this fairly lame because it's restricting us to use only one word answers? Yeah, that's kind of lame. Alrighty, if you've gotten it this far, you can change it to save to a file. We haven't created our file name yet. We haven't created the OF stream yet. We have the variables, but we haven't created those two things yet. So once you get down to there, if you're already ahead of the game, because I'm going to wander around and make sure everybody gets this going, ask for the file name, create the fout, and save the address to fout, then fout close. Instead of create the fout, I should make it fout.open, right? Okay. And I'm going to come back and I'm going to do that as well, So if we felt really awesome, what we would do is we would say, does this look correct? Yes, no. And then if they type yes, offer to save it to a file or whatever. But we're not going to go that far. But I do want to ask for the file name. I want to open the file, save the address, and then close it. So I'm going to do that. Cout arrow quote. Save to what file name? Whatever you made is fine. In space semicolon. CIN arrow file name. Now let's open our file. fout.open. passing in our file name, fout.open file name. If the file exists, we can write to it. So if fout and I'm going to go ahead and put my else clause now. Else cout arrow arrow could not open in space plus file name. Arrow arrow India. Not plus. We're not doing Java. Let me get rid of that plus and change it to arrow arrow. All right. Now here's where the magic occurs. We've already got these statements that save our address in the right format. All I have to do is copy those, paste them, and change the couts to fouts. So I'm just going to copy those 4 lines of code, paste them into my little if block here, and change those couts to fouts. And then call fout.close, and I am done. I should test it out, shouldn't I? All right. 2 to create address file. Alice Weberson. Street number 654, Maine. Stillwater. Okay. 74075. Save to what file name? Address.txt. Press any key to continue. Well, I wonder if it did it. I'm going to go out into that directory and look. Go to my documents folder, my C++ projects, current project, address.txt, open it up, and there it is. Okay, good, good deal. Alrighty, so I think we've hammered in the idea of at least saving to the files and prompting for the file name and stuff like that a couple of times. We didn't do much with reading the input. We've only done that once, but we'll cover more of that next time. So we're going to make a Dropbox for this, and then we're going to do some exam review, which is probably going to be harder than I expected if I'm going to run out of phone battery right this very second. So if you refresh your Dropbox, you'll see folder H. And the BMR assignment, parts 1 and 2, the folders are there for them. Since we're not here next Wednesday, why make the assignment due Tuesday night? So instead you have all, next week to do them. Alrighty. So I need to split the screen so I can pull up some test material without you being able to see it. Uno momento. I guess I'm going to stop the recorder.